Hi guys, welcome to the Art of Server. So in today's video, I'm going to introduce you to a 100 gigabit network kit that I'm putting together. If at the end of this video you're interested in this kit, I'm going to make this available in my eBay store, so go check out the link in the video description. Now, in the recent years, 10 gigabit network has really come down in price, and I know a lot of home labbers are starting to use 10 gigabit networks in your home labs. And today I'm going to kind of take that up a notch, and we're going to skip right over 40 gigabit networks and go straight to 100 gigabit networks. 100 gigabit networks are still pretty expensive, and if you have to buy a 100 gigabit network switch, it's going to be out of the price range of most home labbers. But if all you need is a point-to-point connection, for example from your file server to your main workstation, then it is possible to set up something that is relatively affordable even for a home labber. And so I've put together a kit, and we're going to start with an unboxing of one of the network cards, and then I'm going to show you how to install this and set it up. The setup process for these cards is a little bit more complicated than some other ones, so I'm going to walk you through that step by step. And so anyway, let's get started with the unboxing. So this is actually a HP branded Mellanox card. I believe it is the CX455, I believe. All right, so standard stuff, useless documentation. And so here's the card in anti-static backing. It looks like it comes also with a low profile bracket in case that's what you need. All right, let's go ahead and open this card up. All right, so let me put this aside. So this is the Mellanox CX455A, I believe. It is a single port QSFP Plus port, and it's a by 16 PCIe slot, 3.0 PCIe 3.0, and it's going to need this if you're going to take advantage of the full bandwidth of a 100 gigabit network. All right, so this is the card. The kit is going to come with two of these cards and a QSFP cable that's going to allow you to connect them point to point. So let's go ahead and get over to the lab and install this guy and start setting it up. All right guys, we're in my R630. I've already installed one of these cards in another server, and this is the second server. This is R630. I think I'm going to put this card here, and I've already converted to low profile bracket because there's only a low profile slot here. So I'm going to put that card in this slot. Now, if you're installing these cards, make sure that you are putting it in a by 16 slot, not just physically, but electrically by 16 slot. A lot of servers will have by 16 slots that are only by 8 electrically. So just take a look. In the case of Dell servers, usually you can read on the PCB board or the riser board. It'll tell you which CPU that slot is connected to and how many actual PCI lanes are wired in that slot. So in this case, this slot is a by 16, electrically by 16 slot. So I'm going to be using this slot here. So to get there, I need to remove this riser. And we'll slide this card in here. All right, that looks good. And we'll put this back. All right, so I'm going to close this guy up and we'll go connect the cables in the back. All right, guys, so this is the back of the server where we just installed the card. And this is the cable. I've already got the other end plugged into the server underneath. So I'm going to go ahead and plug this into the card we just installed. All right, you want to make sure that you push it all the way in and you hear an audible click, and that's the latching mechanism engaging, so you know that the cable is fully seated into the card. All right, so I'm going to go ahead and also plug in the power to the server. And we'll log in on the virtual console and start the setup process for this network card. Alright guys, so I'm logged into the iDRAC interface here. I got the machine powered on already. Before I proceed with the setup, I actually want to show you where to find the files that you're going to need. So first thing we're going to need is the Mellanox drivers and tools and stuff like that. So basically you can go to mellanox.com. And under support over here, we can go to the Infiniband VPI drivers. Remember that this CX455A card is kind of a hybrid Infiniband and Ethernet card. So we're going to go under Linux software drivers since I'm running CentOS Linux here. Alright, and under download over here, basically we just pick the version we want, so that's the current one, and I'm running CentOS, so I'll pick the operating system, and the version is 8.2, and the architecture is basically Intel. And so over here, you can download these other files too, but I tend to like to use the tar file here, so this is the one that I've actually already downloaded ahead of time, so you don't have to watch me download the files. But you would click on this, and there's a little, I'll show you. Click on that. There's this end user agreement that you have to agree to. Go all the way to the bottom and say that I've read this and agree to it, and then click accept, and then the download will begin. So that's where you download the Mellanox drivers that we're going to need. And remember that this particular card is a HP branded Mellanox card, and the way the Mellanox cards work, when they're branded, you have to actually get the firmware from that brand. And so in this case, we have to find the HP version of the Mellanox firmware. The generic Mellanox firmware will not apply. Perhaps there is a way to force it, I don't know, but when you try to apply it following kind of the standard procedure, it's going to tell you that, oh, the vendor ID of this card is HP or whatever other brand. Please go contact that brand for support. All right, so finding the HP firmware for this Mellanox card is a little bit trickier, so I'm going to show you how to go about doing that. We'll go to Google first, and you basically want to search by the HP part number. So that's HPE, and actually it looks like I already have it saved here. So it's 825110-B21 and firmware update. Okay, so you'll see that this first link here is an hpe.com link, and it looks like it's the firmware for the HPE Infiniband EDR. All right, so I'll click on that. Yeah, HP's website, by the way, is, I think, horrendous and very hard to navigate, at least for me. I'm not smart enough to navigate HP's website very well, but anyway, it's usually easier for me to find stuff through Google than to try to navigate through their website. But anyway, we get here, and it turns out this is not the latest version. As you can see, this is September 2017. But you know, this kind of leads you into finding stuff. I would click on revision history, and it'll show you that, oh, there was a newer version released on August 26, 2020. So that's the one that we're going to go with. And so basically you can click on that, and it takes you to the page for that updated version. And so now you'll see that we're on the August 26, 2020 release. And so from here, basically you just click on these downloads. One of them is a signature file. It's probably a good idea to check the signature. I've already downloaded these and checked all that out. But basically that's the firmware package, and it's also a tar GZ file as well. Okay, so with those files downloaded and on your server, we can move on to the next step. All right, so this is, I've already logged into the server. This is the R630. I guess kind of show you that. Oh, I don't have that command installed here. How else can I show you? rack ADM, get sysinfo. All right, so here you can see system model is PowerEdge R630. So this is the server where we just installed that Mellanox card. All right, so with that said, I'm in the downloads folder on this server, and you can see that I have those two files that I just mentioned. This is the Mellanox driver package, and this is the HP branded Mellanox firmware package. All right, so first thing, before we even get started, there are a few prerequisites. I have a fairly minimal installation of CentOS 8 on this server, and there are a few tools that we're going to need in order to install these drivers. And so I'll do a DNF install, make gcc g4tran tk lsof python 3.6 tcl and tcsh. So these are just some of the packages that we're going to need. If you don't do this, by the way, as we proceed in the following steps, it will complain and say, hey, you know, missing requirements, please install these things. So I'm just going to do it ahead of time because I've already done this before, and just want to give you guys a heads up on that. All right, so let's go ahead and install these packages. All right, so as you can see, it pulls in a bunch of developer tools. And that's partially because the Mellanox tools are going to rebuild the drivers and stuff like that, I think. So anyway, let's go ahead and hit yes. All right, so with those installed, we're ready to proceed. And the first step is to just basically extract these files. So I'll start with the firmware file, and then I will also do the Mellanox driver package. All right, so you can see that the Mellanox files extracted themselves in this subfolder, while the HP firmware basically just plops down a PDF file and a .bin file. And the .bin file is the actual firmware file. We're going to organize this just a little bit more, so I'm going to create a folder called firmware, and I'll explain why I'm doing this in a little bit when we actually get to do the Mellanox installation. All right, so I'll move the .bin file into the firmware directory, and then I'm going to just remove that PDF file because I don't really need that. All right, so that kind of cleans it up in here, and if I go into the firmware directory, you'll see that I have the .bin file. Let me just change the ownership here, clean that up a little bit. Okay, so the next step is we go into the Mellanox driver package directory. And Mellanox makes this fairly simple. There's basically a script that you can run, and that will basically do everything for you. There are, by the way, a couple different ways to do this installation. I have tried a few of them. For example, since if you're familiar with Red Hat and RPM-based Linux distributions, you might be tempted to use the package manager, like Yum or DNF, to do the installation. And there is a way to set up a software package repository and try to install from that. But what I've found is that the package dependency setup is messed up. So there's some problems there, and basically it's very difficult to install doing that method because it'll basically bomb out and say, oh, this dependency is not met or that dependency is not met. So it was kind of a mess. And so I kind of opted for the install script instead. And so just kind of give you guys a little heads up on that. If you try to use some of the other methods to install, I've found some problems with those. But if anybody else is watching this and you've actually used the software repository method and you figured out how to get that to work, please leave a comment down below and let me and other people know how you got that working, because I kind of had a really difficult time using the software repository. All right, so anyway, the install script is this Mellanox CX455A install. And the reason why I put that firmware in its own directory is because part of this install script gives you an option to point to a directory where you have a firmware file, and at the end of the installation, it's going to try to automatically update the firmware for you based on that directory that you pointed to. Now, if you don't give it a directory, it's going to try to update the card with the stock original Mellanox firmwares. And like I said, those firmwares will not apply successfully using a standard procedure. And so if you just if I just run the command as is, as you see it on the screen, it will do the install. Everything will succeed except the firmware update will fail. And so I'm going to instead add this option called --fw image -dir, and I'm going to give it that firmware directory that we created and where we put the HP branded Mellanox firmware. And so this way, when it's done and attempting to do the firmware update, it's going to see the HP branded Mellanox firmware and apply that, and that will apply successfully. So now you can do this as a separate step. If you could run this without this particular option, the firmware update attempt will fail, and then you can manually go and update the firmware separately as a kind of secondary step. That's perfectly fine as well, nothing wrong with that approach, but I'm just trying to do everything kind of in one quick step. Now, if your card is already fully updated, for example, if you buy my kit that I'm going to have in my eBay store, I will have already updated the firmware on all the cards for you. So you might not need this step at all. But if you are doing this on your own and you want to kind of take advantage of this automated firmware update, then this is what you're going to need to do. All right, so basically you just run the script, tell it where to find the firmware, and just let it go. So it's going to take a little bit of time because it's going to install a lot of different things here. I'll let this record and then come back when it's done. All right, it's going to ask me if I want to continue. I'll say yes. Alright guys, so it looks like all the packages are now installed, and you can see at the very last step here, it installs the Mellanox firmware updater. It finds the firmware that we pointed it to, and you can see that it originally had the firmware 12.18.1000, and it found 12.28.1002, and has now applied that firmware successfully. Now it does say at the very bottom here that you need to reboot or restart the system to take effect. I'm going to show you a shortcut so you don't have to actually reboot the system. All right, so let's figure out first the PCI address of this device. And so you can see that this has PCI address 0500.0. We're going to use that and a command called mstfw reset. Do -- device, and we give it that address, and we'll specify type 0 reset, and basically this resets the whole card, and it'll start up with the new firmware. All right, so I'll go ahead and hit enter and say yes. All right, so at the very end you see that firmware was loaded successfully, so we can check that by running mst flint. And by the way, if you're interested in updating the firmwares on Mellanox cards, I actually have a separate video where I made quite a while ago. I'll put a link to that video if you want to check that out. But I'm using kind of a similar tool here to check on this device. And so we'll again use the PCI address and run a query. And as you can see, the firmware version is the 12.28. 1002, release date of 2020, July 23rd. So we are indeed now running the latest firmware update. All right, so that's pretty much it in terms of setting up the driver packages. But remember that this card is an Infiniband card, and so by default it is in Infiniband mode. And we want to switch that to Ethernet mode so we can use this as a Ethernet device. And so I'm going to show you how to go about doing that. First thing we're going to do is run mst start, and this basically starts some drivers to allow us to look at the device. And so if you do mst status now, you'll see that there is this device. This is basically like a control channel to allow you to communicate with that Mellanox card. And we're going to use this to change the configuration of that port from Infiniband, the default, to Ethernet. And so let's first run mlx config-d, and we're going to give it this device path, and we'll do a query. And this is going to give you a lot of information, so to spare you the mess of stuff it's going to spew out, I'm just going to filter out for link type. All right, so you can see that link type on port 1, so that's what the P1 is in IB mode, or mode number 1, which is Infiniband. And so that's the mode that we're going to change. And so again, we're going to go back to this command, and instead of query, I'm going to do set link. Here, actually, let me widen this a little bit so you can see the whole command on one line. All right, link underscore type P1. So that's the port that we saw earlier. That is, oh, where's the output of that? Here, let me rerun. All right, I just want to be able to show you that. Okay, so we have link type link type for underscore P1 is Infiniband. All right, so let's go back here. We're going to do set link type P1 equals 2. And so mode 2 is the Ethernet mode. Mode 1 is the Infiniband mode. So we're going to go ahead and apply that. And of course, it's going to tell you, please reboot the machine, but we're going to use that same trick we just did earlier to reset the card. And we should be able to basically have it start up with the new mode without actually rebooting the entire server. All right, so again, it's mst fw reset -- device, give it the PCI address -- type 0 reset, and go ahead and enter that. All right, so at this point we can do mst status. We check that the card is actually available, and we will do the query again. And as you can see, last time it said Infiniband, and so this time it should say Ethernet. All right, so as you can see, it is now in mode 2, which is Ethernet. And so at this point, if you do a nmcli device, you can see that we have now a fifth interface that just came up, and I guess Linux is automatically trying to configure it here. But anyway, if I do ifconfig, you will also see that right here. And if we run ethtool to get some information on that, you will see that it is indeed a 100 gigabit card, right? So I actually already have this attached, and the other end is also already configured, and so you can see that it already detects the link, and it's that direct attached copper cable, and it's already linking at 100 gigabits. I'm going to also just configure an IP address real quick here and verify that I can ping the other side at layer 3. So I'm going to look at the device here. Yeah, it's trying to get a DHCP. There's no DHCP server on the other end. And so this is, I guess it automatically configured a wired connection 1. And so we'll just go ahead and use that. I will modify that wired connection 1 with IPv4 address, and we'll use 10.0.0.1/24. I will set the method to static, and let me kind of restart. All right, so now it should show that it's connected. Yep. And do connection show. Yep, so everything looks good. Let's take a look at the IP address on that. And indeed, it has the 10.0.0.1 address with the 24-bit subnet mask. So at this point, I believe I can ping the other side. I believe the other side is at .3. So let's see if yep. So we are getting a successful ping. So basically now we have the IP network set up on this 100 gigabit Ethernet link. All right, guys, before I close out this video, I figure got to show you guys a benchmark, right? All right, so I've got two terminals pulled up here. On the left side is the R630, and I have HTOP running on the top, and I have a terminal on the bottom side where I'm going to run the benchmark. And on the right side, same setup. I have HTOP on top and a terminal on the bottom where I will set up the server side of the benchmark, and that is basically on the other end of that cable. All right, so I'm going to go ahead and just run iperf on this side as the server, and this side will be the client. So we'll connect to that at .3, I believe. And so let's just run a really quick, simple benchmark with just kind of basic settings. All right, so as you can see, with the kind of basic benchmark iperf benchmark, we're getting about 26.5 gigabits per second. So definitely more than 10 gigs, but it's not the full 100 gigs, and it's usually a little bit hard to achieve a full 100 gig with just one stream. And so we're gonna have to multiply that by doing multiple streams. So let's say I pick out 8. So -P is for parallel, and so the number of streams we're going to run in parallel is 8 here. So let's see how this fares now. All right, so as you can see, with 8 streams, each one with varying degrees of throughput, but we have an aggregate throughput down here of 92.9 gigabits per second. So that's pretty much as good as we're going to get to the theoretical 100 gigabit throughput limit. So anyway, I just wanted to show you guys kind of a quick benchmark to show you that this 100 gigabit network actually works. All right, so keep in mind that if you're using an application to connect over this 100 gigabit network, if that application isn't able to use multiple streams of connections, it's going to be very hard to achieve that full 100 gigabit bandwidth. So definitely you need to use something that can split up that connection into multiple streams and basically transmit the data in parallel in order to really take advantage of the full bandwidth capability of this connection. Alright guys, so that's it for today. I hope you enjoyed it. I hope you liked it. If you did like it, make sure you give me that thumbs up. And if you're new to this channel and you like this sort of stuff, be sure to subscribe. Also, if you'd like to support my channel, check out my eBay store. I've got all sorts of server goodies, as well as this 100 gigabit network kit with the cable included. And I'll leave a link down in the video description below, so go check those out. Alright guys, thank you very much for watching and have a great day. Bye-bye.